everyone, myself Neha Shah from LG Institute of Engineering and Technology from the Department of Electronics and Communication Engineering. Today I am going to explain you some examples based on Trigonometric Fourier Series from the subject of Signal and Systems from the third unit, which one is Introduction to Fourier Series and Fourier Transform. In the last session I have started this third unit, which will be based on Fourier Series and Fourier Transform. So in the last session I had already explained you what are the requirements of the Fourier Series or Fourier Transform and which are the types of the Fourier Series. From that, the first type is Trigonometric Fourier Series. So we will be solving some example based on that. Recalling with the equations of the Trigonometric Fourier Series, x of t equals to a0 plus summation n equals to 1 to infinite an cos n omega 0 t plus summation n equals to 1 to infinite bn sin n omega 0 t. In this, we have taken the value of a0 equals to 1 upon t0 integration t to t plus t0 x of t dt. The value of an equals to 2 by t0 integration t to t plus t0 x of t cos n omega 0 t dt. And the third one is bn. The value of bn equals to 2 by t0 integration t to t plus t0 x of t sin n omega 0 t dt. Now, if we want to solve any example to find out its trigonometric Fourier series, so for that, first of all, we have to find out the coefficients of a0, an and bn. To find out the values of a0, an and bn, we have to find out the value of x of t as well as the value of fundamental duration t0. If we are putting all the values in the equation of this t, then we can solve this and we can find out the value of a0, an and b. After finding the values of these three, we will put in the values in this equation to find out its final answer of x of t. So starting with the first example, which one is determine the trigonometric Fourier series representation for the square wave depicted in the below figure. The figure is given to you like this. X of t is given to you. For the range of minus ts to ts, its value will be 1. And for the value of ts to t minus ts, its value will be 0. So from this graph, first of all, we will finding the value of x of t as well as its fundamental duration t0. Okay. So if we are solving this example, first of all, we will finding the value of x of t equals to 1 for the range of t in between minus ts to ts, and the value of fundamental duration t0 will be considered as t. Why? Because you can see that this term will be repeated after t seconds. If we are considering the middle square will be starting with minus ts. The next square will starting with t minus ts. So minus ts, after minus ts, the next square will starting with t minus ts, right? So it means after addition of capital T, it will repeating in the next. So we can say that the fundamental duration t0 equals to capital. Now, if we are finding the value of omega 0, the value of omega 0 equals to 2 pi by t0. So, the value of t0 equals to t, so this value will convert in the form of 2 pi by capital T. Okay. Now, we are putting these two values in the equation of a0, a and bn to find out the value of x of t. As you know that the final value of trigonometric Fourier series x of t equals to a0 plus summation n equals to 1 to infinite an cos n omega 0 t plus summation n equals to 1 to infinite bn sin n omega 0 t. In this equation, we are finding the value of a0, an and bn with the help of this two things. Okay. In this example, you can see that from this graph, we can say that this signal will be even symmetrical signal, right? Because if we are holding x of t, it will gives you the mirror image on the x of minus t side. So if we are applying the even symmetry in this example, so the value of bn equals to 0 for this particular example. So just we have to find out the value of a0 and an. Now starting with the equation a0 equals to 1 upon t0 integration t to t plus t0 x of t dt. In this equation, we have to put the value of x of t equals to 1 for the duration of minus ts to ts, right? So the range will change from minus ts to ts, the value of x of t equals to 1 and the value of capital T0 equals to capital T. Now if we are integrating 1, as you know that the integration of 1 with respect to t, so the answer will be t and the range will be minus ts to ts. Now if we are applying this range over here, so the higher range minus lower range. So the term will be ts minus ts, it means 2ts. 2ts by capital T, this one is the final answer of the coefficient of A0. Now we will finding the second coefficient, which one is an. Value of an equals to 2 by t0 integration t to t plus t0 x of t cos and omega 0 t dt. In this equation, we will put in the value of t0 x of t and also we will put in the value of omega 0 as well as we will changing this range of integration. So the next step will be 2 upon capital T, the range will be minus ts to ts, the value of x of t equals to 1 cos and omega 0 t dt. Now, as you know that 1 into cos, it means it will give you the final answer as cos and omega 0 t. And the integration of cos and omega 0 t equals to sin and omega 0 t divided by n omega 0. And the range will be minus ts to ts. Now, if we are putting this range over here, so as you know that higher range minus lower range. So instead of t, we'll first taking the value as ts and then instead of this t, we'll taking the next value as minus ts. So the next step of an equals to 2 by capital T sin n omega 0 ts minus sin minus n omega 0 ts divided by n omega 0. Here we will apply the rule as sin of minus theta equals to minus sin theta. So this minus plus, so the term will be sin n omega 0 t plus sin n omega 0 t divided by n omega 0. These two terms will be same, so it will consider as 2 times sin n omega 0 ts. So here we have applied the rule as sin minus theta equals to minus of sin theta. Now if we simplify this term, so it will give you the term as 2 sin n omega 0 ts divided by n omega 0 and 2 into 2 means 4 times sin n omega 0 ts divided by n omega 0. If we will simplifying the value of an by putting the value of omega 0, then the next step will be an equals to 2 by t in bracket 2 sin n into 2 pi by capital T into ts, because the value of omega 0 equals to 2 pi by capital T, right? Divide by n into 2 pi by capital T. Now if I am simplifying this, t will be cancelled out and this 2 will be cancelled out. So final answer will be 2 upon n pi sin n into 2 pi into ts by capital T. So the final term will be sin 2n pi ts divided by capital T. So this way we can find out the value of a0 and an. Now the next step is bn. The value of bn equals to 2 by t0 integration t to t plus capital T0 x of t sin n omega 0 t dt. As I have told you that this signal is even symmetrical signal, so the value of bn equals to 0. So if we are putting the value of a0, an and bn in the equation of x of t, so the final answer of x of t equals to 2ts divided by capital T plus summation n equals to 1 to infinite 1 upon n pi sin 2n pi ts divided by capital. So this way we can find out the example of trigonometric Fourier series using waveform symmetry. Now the next example is determine the Fourier series representation for the signal x of t shown in the below figure. Here we have not mentioned which kind of Fourier series we have to find, then you have to take it as the trigonometric Fourier series by default. Okay, so we have to find out trigonometric Fourier series for this example. Now from this graph you can see that on the positive side it will be in the increasing form and in the negative side it will be in the decreasing form. So this kind of signal we consider as odd symmetrical signal. And if it will be odd symmetrical signal, so if we apply the waveform symmetry, so you can see that the value of A0 and An equals to 0, so just we have to find out the value of Vn. And to find out the value of Vn, first of all we have to find out the value of x of t as well as the value of fundamental duration T0. So starting with solving this example, first of all we are finding the value of x of t. X of t we consider as it is ramp signal, right? For the range of -1 to 1. This ramp signal will be in the repeating form. So I will write down x of t equals to t for the range of -1 to 1. Now what will be the fundamental period for this? The duration of -1 to 1 will be in the repeating form. So the higher value minus lower value we consider as fundamental period. So the value of t0 equals to higher value means 1 minus the lower value means -1. So 1 minus -1 means plus 1. So 1 plus 1 means 2. So the fundamental duration t0 equals to 2. Now if we are finding the value of omega 0, then the value of omega 0 equals to 2 pi by t0 and the value of t0 equals to 2. So the value of omega 0 equals to 2 pi by 2, it means pi. Now, if we are taking the equation of trigonometric Fourier series, then its equation will be x of t equals to a0 plus summation n equals to 1 to infinite an cos n omega 0 t plus summation n equals to 1 to infinite bn sin n omega 0. In this equation, I will take the value of a0 equals to 1 upon t0 integration t to t plus t0 x of t dt. And the value of an equals to 2 by t0 integration t to t plus t0 x of t cos n omega 0 t dt. But as you know that the given signal is odd symmetrical signal, so this two values will become equals to 0. So as the signal is odd, so using odd symmetry, the value of a0 and an equals to 0. So just we have to find out the value of vn. So if we are finding the value of Vn, the equation of Vn equals to 2 by t0 integration t to t plus t0 x of t sin n omega 0 t dt. Okay. In this equation, instead of x of t, we are taking the value as t, and instead of this range, we are taking -1 to 1. Instead of value of t0, we are taking its fundamental period as 2, and instead of omega 0, we are taking its value as pi. So the final term will be 2 by 2 integration -1 to 1 t into sin n pi t dt. Okay. Now 2 will be cancelled out, so its value will be 1. 1 into this term will give you that term. So if we are applying the rule of integration, like integration of t sin at dt equals to 1 upon a square sin at minus at cos at. In this equation, so the next term is Vn equals to 1 upon n pi square because the value of a equals to n pi. If you will comparing these two equations, okay. So 1 upon n pi square sin n pi t minus n pi t cos n pi t, and the range of this term will be -1 to 1. Now we will apply this range over here. So first of all, we are taking higher range, which one is 1. Then we will apply the lower range as -1 to this. So higher range minus lower range, it means, so the value of Vn equals to 1 upon n pi square in bracket sin n pi minus n pi cos n pi minus in bracket minus sin n pi plus n pi cos n pi. Now if we simplify this term, minus this term will be plus sin n pi plus sin n pi means 2 times sin n pi. And this minus goes over here. So minus n pi cos n pi minus n pi cos n pi equals to minus 2 times n pi cos n pi. Now as you know that the value of sin n pi equals to 0 for any values of n. So the term will be minus 2n pi cos n pi on 2. Now if we are cancelling n pi, so the final answer of Vn equals to minus 2 upon n pi cos n pi. Now if we are putting the value of Vn in the equation of x of t, so the final answer of x of t equals to summation n equals to 1 to infinite 1 upon n pi square minus 2n pi cos cosine pi into sine and pi. So this way we can find out any examples of trigonometric Fourier series using waveform symmetries. So the calculation will be reduced by reduction of number of coefficients. In the next session, I will start with the next type of Fourier series. Thank you so much.